Here we're going to look at an example of adding or subtracting polynomials with an application. So we have someone who's dropping a penny from the top of or from 200 feet up on a building, and at the same time someone else is dropping a paintbrush 75 feet up on a building. So each of these polynomials represents the heights in feet of the penny or the paintbrush after t seconds. So t would be the amount of time that has elapsed since they dropped the object. Suppose the polynomial represents the negative 16t squared plus 75 of the paintbrush after t seconds. What we want to do is write a polynomial that represents the distance between the penny and the paintbrush after t seconds. So what is this distance going to be between the two of them after each second of time has elapsed? Well, in order to find a distance between them, we would want to think about this. Would we be adding them together? Or if we're finding a distance between, would we want to subtract? Finding a distance between is going to be a difference, so we're going to subtract. So what we have is negative 16t squared subtract 40t plus 200 as the polynomial for the penny, and we're going to subtract the negative 16t squared plus 75. Because the penny started out higher, that's going to have the larger value. So that's why we want to start with that polynomial, subtract the height of the paintbrush, because that has a lower height or a lesser height. Keep in mind, when we subtract polynomials, you want to distribute this subtraction. So let's rewrite this, distributing that subtraction. Negative 16t squared minus 40t plus 200. Negative times negative becomes a plus 16t squared. Negative times a positive, minus 75. And now let's simplify. Let's combine our like terms. Negative 16t squared plus 16t squared. Those are opposite values. They will cancel out. So we don't have to worry about a quadratic in our equation or our polynomial if we're going to use it to evaluate, since we're not familiar with the quadratics just yet. Then we have negative 40t as our term with the next highest degree. So negative 40t. And then we have our constants. 200 subtract 75 is a positive 125. So this polynomial represents the distance between the penny and the paintbrush after each second of time has elapsed. So now we need to interpret the coefficients of this polynomial. So if I want to interpret what the 125 means, we need to consider, well, if t is 0. So when we first drop our objects, that would mean this 125 is the distance between the objects when they first drop the penny and the paintbrush. So we can say 125 represents the distance in feet between the objects when they are first dropped. But what about the negative 40, the leading coefficient? Well, if we think about this in terms of being a linear equation, this would be a rate of change. So this would be telling me how close the objects are getting to each other, or how that distance is changing between the objects each second in time. So negative 40 represents how much closer the objects are to each other after each second. So yes, we can use adding and subtracting polynomials when it comes to applications.